Okay, we're going to look at finding the limit of a piecewise function. Here's an example given to us. So we have x squared plus 3, and that is defined for the piece x is less than 1. And we have the natural log of x plus 2. That's defined by the piece x is greater than or equal to 1. So we see three limit questions here, and notice that the x value that we're approaching matches where the rule is changing. So we want to find the limit as x approaches 1 from the left, from the right, and then from both directions. Well, to help us understand this principle, it might be beneficial, at least the very first time, to sketch a picture of what's happening here. So here's one. If I were to draw x squared plus 3 for values less than 1, we're just going to sketch this here. At 1 we would have an open circle, and if we were to plug 1 back into x squared plus 3, we would get 4. So we know we have an open circle there, and then I've drawn part of my x squared plus 3 graph. Let's take the second piece, the natural log of x plus 2. If we plug 1 into that piece, well, the natural log of 1 plus 2, that's 0 plus 2, that would give us 2. So when we plug 1 in, we have a y value of 2. So this natural log function would slowly rise. That plus 2 is not part of what you're taking the log of. It's just going to shift up your natural log of x graph 2 units. So that's what the two pieces would look like. Well, we're not always able to sketch a picture, nor do we really want to bother wasting our time sketching a picture. But it's helpful, at least in the beginning, to understand the principle. Well, if we're approaching 1 from the left really implies less than. So we want to use the piece that is less than. So as we are approaching 1 from the left, we need to use this x squared plus 3 piece. So even though 1 is not defined, we're still going to plug 1 into that piece, which we already did earlier, and we're going to get 4. Likewise, 1 from the right, we get closer and closer to 1 from the right. So we plug 1 into this piece, and we said earlier that's going to give us 2. So from the right, you want to use the greater than piece. From the left, you want to use the less than piece. So 1 from each direction, well, we have to look at the two one-sided limits. Since they do not match, then every single time when that is the case, the overall two-sided limit would be dne.